In this tutorial, I will be teaching the basics of FM synthesis using Operator, which is a stock synthesizer on Ableton Live. I'm also going to use Spectrum on the same channel, which is a frequency analyzer, to help give you a visual representation of how the waveforms are being affected in frequency modulation synthesis. Here is Operator. If you look on the left side, you can see the letters A, B, C, and D. Each of these letters represent an oscillator that can generate a non-audible sound wave and be used to modulate another oscillator's frequency. In this case, oscillator A will be the main oscillator, or in other words, sound generator, while B will modulate A, C will modulate B, and D will modulate C. So we'll just have a listen to oscillator A first, and then we can add the modulating oscillators later to thicken up the overall sound. So here in oscillator A, you can choose what type of waveform you want to generate and what frequencies you want to generate. And I'm going to use a sine wave and only use the low frequencies to develop a sub-bass. So I will draw out the unneeded frequencies here in this orange rectangle. You can think of this as being similar to an equalizer. If you look at Spectrum, you can see how the sine wave will be modulated when I engage the LFO. In case you don't know, a LFO is a low frequency oscillator that is used as a modulator wave to modulate the main oscillator's frequencies. In the LFO section, you can choose different types of waveforms to modulate the main oscillator, and in this case I will be choosing the saw up wave. Next to this are two pots, rate and amount. Rate will determine how fast the modulation happens, and amount will control how much modulation happens. So let's have a listen. If you watch Spectrum here, you can see how this saw wave on the LFO is modulating the main oscillator's sine wave, changing the frequency content and waveform. This simply explains what is happening in frequency modulation synthesis. There is one or several modulation waves modulating the main oscillator's frequencies and waveform. Now I will add in the other modulator oscillators to thicken up the sound and add more mid to high end frequencies. Now as you can hear, there is a lot more frequency modulation occurring. D's triangle wave is modulating C's square wave, and C's square wave is modulating B's waveform. And then there's B's waveform that is modulating oscillator A's waveform, which is then producing the audible signal. The overall waveform now has a broader range of frequencies and sounds much more like a synth. I hope this has helped you in understanding the basics of FM synthesis. Thank you for watching.